We'll practice organizing velocity time data to check for uniform acceleration, find the acceleration, and calculate displacement. Here's the problem. A student records velocity time data for a car on a track. The times are 0, 2, 4, and 6 seconds, and the corresponding velocities are 4, 10, 16, and 22 meters per second. We need to organize the data and determine if the acceleration is uniform, then find the acceleration as the slope of the v-tie graph, and finally find the displacement over the 6-second interval as the area under the graph. First, we check for uniform acceleration by computing the successive changes in velocity over each 2-second interval. From t equals 0 to t equals 2 seconds, the velocity changes from 4 to 10 meters per second, a change of 6 meters per second. From t equals 2 to t equals 4 seconds, the velocity changes from 10 to 16 meters per second, also a change of 6 meters per second. From t equals 4 to t equals 6 seconds, the velocity changes from 16 to 22 meters per second, again a change of 6 meters per second. Since each change is the same, 6 meters per second over each 2-second interval, the acceleration is uniform. Now we determine the acceleration as the slope of the velocity time graph. Acceleration equals change in velocity over change in time. Using the first and last points, the change in velocity is 22 minus 4 equals 18 meters per second, and the change in time is 6 minus 0 equals 6 seconds. So acceleration is 18 divided by 6, which is 3.0 meters per second squared. Finally, we find the displacement as the area under the velocity time graph. The shape is a trapezoid. Displacement equals 1/2 times the sum of the initial and final velocities times the time interval. So 1/2 times 4 plus 22, which is 26, times 6 seconds. 1/2 of 26 is 13, times 6 gives 78 meters. The key takeaway is that for uniform acceleration, the velocity time graph is a straight line, and the displacement is the area under that line, which can be found using the trapezoid area formula.